All right, let's look at chapter 2 here in A&P 1. All right, so chapter 2 deals with chemistry, and chemistry is the study of matter. Well, what is matter? Matter is anything that has mass and takes up space. So it's literally everything that's around us. So mass is the amount of matter in an object. And just to let you know, a lot of times mass and weight get interchanged, and they actually mean something different. Mass is the amount of matter that's there. Weight is the gravitational force acting on an object of a given mass. So my weight can change just by the amount of gravitational force that's applied to the mass that is my body. All right? So let's take a look at inorganic chemistry. This is a study of non-carbon compounds. All right, so essentially what we're going to look at is basic chemistry. And so we're going to start off looking at elements. And an element is a basic chemical substance. There are 120 known elements. 92 of those elements are naturally occurring. So the rest of those we made in a lab. All right. Now each element has its own unique atom, and we'll get to how that is here in a little bit. So oftentimes when you see an element listed here, you'll also see a chemical symbol for that element. So a chemical symbol is a shorthand version of the name of an element. This can be 1 or 2 letters in length, and typically the first is capitalized, and the second is in lowercase. All right? So, you know, we see carbon is C, hydrogen is H, nitrogen is N, oxygen is O, phosphorus is P, sulfur is S. All right? But then when we get to other things like, you know, here's calcium. Well, we've already used C, so we use Ca for calcium. All right? You can see, you know, here some of these don't seem to make sense. Here's iron, Fe. That comes from the Latin word for iron, which is ferrous. So, you know, sodium is Na right there. So that comes from the Latin word natrium, which means salt. All right, so that's where they got those. Now, of these, a lot of these are what we call bulk elements. That's a basic chemical substance needed in large quantities by life. All right, so there are 6 bulk elements. That's carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. All right, now they make up 95% of life by mass. All right, now this is looking at common elements of the human body. So some of these are going to be moved up or down depending on the organism. All right, so for us, you know, like sodium is higher here and so on. So this is showing percentage of atoms there. You know, and calcium is a little high there as well. You know, like plants and, you know, trees, they don't have that high calcium levels. The rest of the elements are what are known as trace elements. These are basic chemical substances needed in small quantities by life. All right, let's take a look at atomic structure. And we're going to look at this in 2 ways. One way is through what is known as a planetary model, and the other is electron cloud model. This is a little better representation of what an atom is. All right, so planetary model is like this to show like the nucleus is like the sun, and the electrons are like planets that revolve around the sun. All right, so it's an easy way to start off just basically talking about an atom. So the nucleus is a central portion of the atom, and within the nucleus, what we can find are protons, and protons are positively charged subatomic particles. And also found in the nucleus are neutrons, which are neutral subatomic particles. And then flying around the nucleus are electrons, and electrons are negatively charged subatomic particles. They're not found within the nucleus. All right. Now, an electrically neutral atom will have the same number of protons and electrons. So those positive charges and negative charges will cancel each other out. So the first aspect of an atom that we're going to talk about. So why the electron cloud is a little better is, you know, this is trying to say those electrons are found in a certain area, and the electron cloud model says, well, they're not found in a certain area, and that's actually the way they are. So the first aspect that we're going to look at with atoms is what is known as the atomic number, and this is the number of protons in an atom. So for this is looking at helium. It has 2 protons, so its atomic number is 2. The number of protons in an atom identifies the element. So if we had 2 protons, it's always going to behave like a helium atom. If you add another proton, well, that makes it a lithium atom, and it will no longer behave like a helium atom. It will now behave like a lithium atom. All right? Next is mass number, and mass number is the number of protons and neutrons in an atom. Essentially, we're looking at the mass of that atom. All right? So you take the number of protons, the number of neutrons, that's the mass number. And if you're wondering, why didn't we also include in there electrons? Well, electrons are very, very small. They're literally 1/1800th of the size of a proton. So very, very small. Their mass is almost negligible. All right? So one of the things that we can do with an atom is we can change the number of neutrons, or we can change the number of electrons, and it'll still be the same element. If we change the number of protons, it becomes a different element. So let's take a look at changing the number of neutrons. And this is what is known as isotopes. And this is an atom of an element that has a different number of neutrons. So isotopes are atoms of an element that have different number of neutrons, or another way you could say that is they have a different mass number. And this is showing the 3 different isotopes for hydrogen. And I will tell you, hydrogen is the only element in which they have actually named these different isotopes. So this is typical hydrogen here. There's actually no neutron in a typical hydrogen. This is what is known as called deuterium. It has 1 neutron. Deuter means 2. Tritium means 3, so it has 2 neutrons in there. So here the mass number there is 2, there the mass number is 3. Okay, so most of the time we just name the element and we put its mass number afterwards. So like you've probably heard of carbon-14. So normal carbon is carbon-12, carbon-14 is a radioactive isotope of carbon. Next is the atomic mass, and this is the average mass of an element's naturally occurring isotopes. So, so if we go back to this picture here, they're showing atomic mass. As you can see with hydrogen, it's 1.008. So what we're saying here is the vast majority of hydrogen atoms that are out there are regular hydrogen. Same with carbon. Carbon is 12.01. Most of the carbon atoms are regular carbon. So next is a molecular form. Next is an ion, and an ion is a charged particle. This is an atom or a group of atoms that has either gained or lost an electron. So if it has gained an electron, that atom becomes negative. Right? So let's just look at an example here. Here's hydrogen. It has an atomic number of 8, so it has 8 protons, 8 electrons. So 8 protons in the nucleus, 8 electrons flying around. If it gained 1 more electron, well then it would have 9 electrons. And so the number of electrons would be greater than the number of protons, so it would have an overall negative charge. Conversely, if it lost an electron, so got rid of this one over here, right, then it would have 7 electrons and 8 protons. So the number of positive charged protons would be higher than the number of negatively charged electrons. So, and here's a simple little joke to help you remember this. So 2 atoms are walking down the street. One atom looks at the other one and says, "Hey, I think I lost an electron." And the other one says, "Are you positive?" Dun-dun-dun. All right, so you'll never forget it. All right. Next thing is a molecular formula. A molecular formula is a shorthand version of the name of a compound. So instead of writing out dihydrogen monoxide, you would write H2O, which is commonly known as water. So H2O is the molecular formula. So another thing that we see are electrolytes. Electrolytes is a substance that ionizes in water to form solutions capable of conducting an electric current. All right. So an electrolyte is going to separate into ions. So if you take regular salt, sodium chloride, and you put it into water, it will separate into sodium ions and chloride ions. All right, and so that would be an electrolyte. So a lot of salts are electrolytes, acids and bases are electrolytes as well.